Hi guys, how you doing? So in this lesson, we'll talk about real world applications of the sine law and the cosine law, how we did in 8.1 and 8.2. So it really is a real life application. So imagine a boat on the ocean coming from, I don't know where, but it's coming from somewhere. And a way that people can determine how far away it is from the shore, or how long it's going to take to get to the shore, or even its speed, is to use two different radars. So you have two radars. You have this radar and that radar A and B. So this radar can shoot a radio wave that travels so fast, and that radio wave comes back. That radar is able to determine the angle from that radar at which that boat is. Then another radar at a certain distance away, in this case it's 500 feet away, does the same thing and then gets a certain angle. The two angle measurements and the distance between the radars can be used, and this is with the sine law, to determine how far away the ship is or how long it's going to take to come to shore. The same application or the same idea is used for airplanes, how they determine when the airplanes are communicating with the ground people and trying to figure out whether or not it's safe to land. This is how they communicate with them to direct them and keep you guys safe. So in this question, they want us to figure out the distance from the boat, the distance of the boat from station A and the distance of the boat from the shore. So if this is station A, they want us to find this distance, let me call it x. And they just want us to find the distance of the boat from the shore. That's going to be the perpendicular distance of the boat from the shore, like perpendicular distance, just that's what it is. That's what that's asking for. So in that triangle, I hope you see I have one side and I have two angles. So I have angle, side, angle. I'm just going to use sine law. I need to find the distance x. I do not know what this angle is, but that angle can be found. Interior angle sum, 70 plus 60, and that's subtracted from 180 gives you, we don't know, 180 minus 70 minus 60, 50 degrees. 50 degrees. Some of you are laughing at me for not knowing that, but alright, so that's 50 degrees. I'm going to say sine of 50 divided by 500 is equal to sine of 60 divided by x, and this will give me x as 500 sine 60 divided by sine 50. Remember, you need to put this in your calculator all at once. So when I put that in my calculator all at once, I have 500 sine 60 divided by sine 50, 565.3 feet. To the nearest whole foot, so that's just 565. It says nearest whole foot, right? So that's just 565 feet. The other thing it's asking for is to find the perpendicular distance. When it says distance of the boat or distance of the boat from the shore, yeah, that's asking me for a direct straight line distance. If you're at the boat and you wanted to get to the shore, you're not going to take this path or that path, you're just going to go directly to the shore. So that straight line distance is the height of this triangle. And I hope you can see that using any of these things, I can use sine, I can use the 70 degree angle, that 70 degree angle, and say sine of 70 is equal to the height divided by the hypotenuse, which is x, which I've just found as 565. So the height is 565 times sine 70, which gives me 565 sine 70, 530.9, which I can round up to 531 feet. Alright, so we just use the sine law to solve a real life problem or application. However, in real life, technically, there's no one who's sitting around doing this mathematics. Computers are programmed with just the values of these two angles because the distance is constant. The program with the values of those two angles, and once you punch them, you punch in the angles from the two radars, it just automatically computes the distances and gives them to you. However, that computation is only possible because someone programmed it using knowledge of the sine law. So, yeah. Airplane flies 220 miles with a heading of 40 degrees, okay? Then flies 180 miles with a heading of 170 degrees. How far is the plane from the starting point and at what heading? Alright, let's see. So, airplane starts out here, flies at a heading of 40 degrees. Now, usually these degrees are measured from the north. So 40 degrees off of the north, that's just this 40 degrees. And then that happens for 220 miles. Let's make it longer. 220 miles. And then after that, I draw another compass direction. It goes on a a heading of 170 degrees. So from here, 170 degrees is going to be, if this is 90, 170 is going to be somewhere here. And that is 180 miles. 180 miles. So that's a bit shorter than the previous one. So wherever it's going to end up, let's say it ends up somewhere here. Okay, so I have a triangle, or I have a big triangle, and this is the distance from where it started to where it ends up. So it's asking me how far is it from its starting position and at what heading is it from its starting position. So I need to find this value of x, and I also need to find this angle here, how far it is from its starting position. So I can do some geometry to figure out the sum of the angles. For example, since this is 40 degrees over here, and I know that alternate angles are equal, that means this angle inside here will also be 40 degrees. And I've been told that all the way here is 170 degrees. So that means the inside part here is 10 degrees, because I only need 10 to make 180. I end up having a triangle in which this is 50 degrees, because it's the 40 plus the 10, 50 degrees. This is the x that I want. That's 180 miles, and that's 220 miles. So that triangle is set up for me to use the cosine law. Hope you can see that. The cosine law says that x squared will be equal to 220 squared plus 180 squared minus 2 times 220 times 180 cosine 50. So plug all of that into a calculator, take the square root, 220 squared, 180 squared, minus 2 times 220 times 180 times cosine 50. So I get 172.8 or 0.9. I said nearest tenth, so 0.9 feet. Is it feet? Miles. Alright. The next thing it wants me to find is its heading from its starting position. So from its starting point, its heading is going to be, I'll get the heading using this angle. Let me first find that angle. If I want to find this angle, I can either use the sine law, since I now have x, or I can use the cosine law. If I call this angle A, then the cosine of A will be equal to, remember, b squared plus c squared minus a squared. A squared is the one you subtract. Or let me write this the same way that I said it yesterday. Subtract a squared, that means it's b squared plus c squared divided by 2bc. So I'll have 220 squared plus the one I just got, 172.9 squared, minus a squared, which is 180 squared, all divided by 2 times 220 times 172.9. So I put that in a calculator and find its inverse cosine. Find its inverse cosine, and that's what will equal A. So inverse cosine, let's go. 220 squared plus 172.9 squared minus 180 squared divided by 2 times 20 times 172.9. Finding the inverse cosine. That's the cosine. Inverse cosine. Alright, so I have 52.9 degrees. That's what I get, 52.9 degrees. So remember, this angle is 52.9 degrees. It doesn't mean that its bearing is 52.9 degrees. If I try to draw this better, I'm going to try and draw this section here better. The one I just circled. I have 40 degrees going up there, right? And then between 40 and whatever line this is, that's 52.9 degrees, right? Now I hope you can see that all together that adds up to give you 90 something. Oops. Okay. If I add the 40, that gives me 92.89 degrees, right? So it's even beyond the 90 degree angle. It's beyond the 90 degree. What that means, since that's 92, the total is 92.9 degrees. That means that his bearing from the starting position is 092.9 degrees, right? Or if you want to be very fancy, you can say it's east 2.9 degrees towards the south, because the final thing would be a small angle there, which is just, since this is 90, that means what's left is 2.9 degrees. So that's his bearing, well, that's his heading from his starting position. Yeah. Two planes leave the same airport at the same time. One flies at 20 degrees east of north at 50 miles per hour. So let me sketch that one first. 20 degrees east of north. East of north. This is north, so east of north. So that means this way. And that's 20 degrees at 600 miles per hour. So this is 600 miles per hour. The other flies at 300 degrees east of south. 300 degrees east of south. So this is the first plane. The second plane flies, they leave the same airport at the same time. So the second plane also has to leave this same airport. And it flies 30 degrees east of south. This is south. So east of south is this way, 30 degrees. So it's going like that. This is 30 degrees. This was 20 degrees. The first one was 500. Okay. First one was 500, sorry. Second one is 600 miles per hour. Okay. How far are the planes after 2 hours? So let's try to figure that one out. Okay. How far are the planes? How far apart are the planes after 2 hours? Now, if this is traveling at 500 miles per hour, then after 2 hours, how far away do you think it is from where it started? Well, distance is speed times time. So after 2 hours, that plane is going to be 500 times 2 times 2 miles away, because remember distance is speed times time. So it will be 1,000 miles away, right? And then the second plane after 2 hours will be 600 times 2 miles away, which is 1,200 miles away. So this diagram, even if I had drawn it initially as a velocity diagram, I need to change it to be a distance diagram. So I know the distance that this one is away from the beginning point is 1,000 miles, and this one is 1,200. I can figure out this angle, the angle in between them, right? If this is 30, that means, so I'm basically getting 180 minus 50, which will be 130 degrees. Again, just explaining it better, if the top is 20, then in here I have 70, and if the bottom is 30, then in there I have 60, and 60 plus 70 is 130. So again, you have a triangle in which this is known, that is known, this is known, 130 degrees, and I just need to calculate x. Again, you're going to use the cosine rule. X squared will equal to 1,000 squared plus 1,200 squared minus 2 times 1,000 times 1,200 times cosine of 130. You plug that into your calculator, find the square root, and that's the distance away, or that's how far apart the planes are after 2 hours. Let me plug that in so I show you. 1,000 squared plus 1,200 squared minus 2 times 1,000 times 1,200 times cosine of 130. 1995. Interesting. 1995.7 miles out from each other. So think of if you're living from the same airport with somebody, but you're both going in different directions, then you can always know, if you know the speed of both airplanes, you can always know how far apart you are from each other. Alright, so this is your homework. Enjoy.